My name is Nataša Vujičić and I will be chairman for this session, Industrial Solutions. So we'll have some good software presentations. Our first presenter is not relevant yet, so we'll start with Logit and Rastko sorry. Because we changed the speaker at the last moment. And he will present a solution for his company. And at the end of this session, we will have some polls. So you will just tell us what of this software is most useful for you, for maybe for your research. And vendors will provide you free license for that. So that will be decided in tomorrow. So you can just yes, sure.
We'll answer it to just a second. My name is Dusan, and I would like to thank all of you, our host, Faculty of Organizational Sciences, especially our chair organizer Boris Delgošić, for giving us the chance to participate in such a great event. I know that we are all probably tired, so I will keep it short and simple. I will just try to introduce our company, what we do, and how we encountered the concept of big data through our projects that we are working on. Okay, so what we do is we provide software services and solutions in the fields of retail, distribution, logistics, business intelligence, and many other fields where high volumes of operations and thus high volumes of that data is present and continuously growing. So we have operations throughout Europe and Middle East, and currently we went to the US market as well, where we are participating with some large companies, with our engineers taking part in those projects. Okay, so I have to mention our partners, which are Oracle and Symphony IC. I believe that we don't need to present Oracle furthermore. We all know what is it about our technology partner, but I will mention shortly Symphony IC. We are their partners for retail, wholesale and logistics solutions. Symphony IC is the world's largest, world's leaders in software solutions, providing software solutions in retail. They have 15 out of 30 largest retailers in the world and 25 out of the 50 world largest CPG suppliers. They have very good retail history. They have 25 years of experience in that field of work. Their headquarters is in California, USA, and what is most important, that their support and development centers can be found in 20 countries all over the world. This is just a short list of their clients and their references, just to take the global picture of the size of the company. You can see that most of them are retailers, but not all of them. So they do in all the fields of business. Okay, just a short picture of the references. And what is Logit's main focus is on software engineering. What we do is not just software development, but whole engineering process, from complete from analysis of clients' needs, testing, development, and quality assurance of developed solutions. So we employ engineers from various fields of business who will make sure that our best know-how and our best experience is used during the development and implementation of our solutions. What I want to stress out, what is most important for me, that you know that our team is not made only of software engineers, but also from experts from various fields of industries where we provide solutions for. Okay? So, this is just a short list of the technologies. Some of you may know all of them, maybe more. This is just a short list of the technologies that we use. It's not a complete list, but in light of this conference, I want to note that we have great expertise in Hadoop, Microsoft SQL, Oracle database platforms. Also, we have great expertise with Python, R, SAS, and IBM's SPSS. I heard yesterday that some of the lecturers are mentioning those platforms as the best practices. encountered those, let's say, challenges of big data. Our most recent project is with Alshaya, which is one of the actually largest Middle East retailer. So they have more than 70 franchise brands across the Middle East, Africa, Europe. Actually, they are located in Kuwait, their headquarters, but they have over 2,200 large formal stores across the world. So what is interesting, what was interesting in this project was that they are working with, they operate in 7 different sectors in their field of business, from food to office supplies to pharmacy, and that produces large amount of diverse data, which needs to be presented in a simple enough manner for one manager to be able to see, be able to interpret it without spending too much time. So that was the main challenge. That is actually the main challenge in this project. They're using different systems in the everyday business, which means that different sources of enormous amount of data needed to be handled. Okay. Another interesting project is also from retail sector. It is the Mercator, as largest Southeast Europe retailer. They are employing more than 24,000 employees in their company. And why I'm mentioning them? Because they are great innovators in their business. What we did for them is some cool stuff regarding, we developed them click and collect web application, mobile application for shopping, and what is most important that we managed to incorporate those innovations in their existing supply chain management solutions and warehouse management solutions, and thus creating unified platform for retail. So providing a whole 360 degrees angle point of view, both from suppliers and from consumers, consumers' needs and suppliers' expectations, and how to answer to those consumer needs. So another great project is also from the retail sector, but I will skip it. It is Univer Export. It is one of the largest food retailers in Serbia, and they now implemented new supply chain management and started to work on centralized their data, and started to work on data analysis in more efficient approach. Thus, yet another company that has needs for processing the big data from the retail sector. Okay, so one of the projects that is not from retail sector is Republic Fund for Pension and Disability Insurance. What we did there is create an informational system that will communicate with different systems of social security holders across Europe. This project was funded by the European Union. We designed the system, and the main challenge was to tackle to process the data collected on the daily basis and to gather information from various data sources. So they have our information system is communicated with similar systems across Europe. Okay, so we had the challenge to connect it and to interpret the various different data sources. Okay, and the last project that we are just started working on is the GIS or GIS. Actually, that is yet another tool which we are developing to manage geospatial data. Regardless what the tool is for, it is important to understand the techniques for handling these sets of data is more or less similar, regardless of whether it is geospatial or retail or any other domain, but it is important that the techniques are similar, and the techniques for handling this data are similar, and regardless from the domain that they are coming from. So we are using that geospatial data, we are using sensors. This is something new that we are doing in this region, and we are encountering that, let's say, challenge with large amount of data to best to perform our business operations for our clients. So in geospatial data, we are not just using the data created by users, but by sensors, but with machines and various other services. So I said that I'm going to be brief. I was. If you have any questions, please feel free to check our site, send me email, or we can hear some questions, no problem.
Short and brief.
Yes, I tried to.
Thank you. So if you have any question, please. So maybe I can ask you one question.
No.
Do you have any open solution that you developed so far so you can maybe provide?
We
Works with that Hadoop, with
yes,
decision making.
unfortunately our chief technician wasn't able to come. I'm more from the business part of the business side, and I know that we are using those technologies and open solutions are present working on those projects, but unfortunately I cannot provide you more information about the technical details. So I'm saying again,
So we can contact you.
yes, you can feel free to contact us, send emails, visit our website, and we can provide you more information about the technical details.
Thank you very much.
Thank you.
So now we are waiting for other speaker. Yes.
Automation and arena simulation out of Pittsburgh, Pennsylvania, USA. If you're not familiar with Pittsburgh, it's a small city about an hour east of New York and an hour west of Chicago. So today I want to, we've been working with this team for a while to share Arena with the conference. And today we just want to present what Arena is and show you a couple example models of it. I can see everybody on the screen. Has anybody worked with Arena before? Anyone?
No. So you can
Okay.
start.
Sure. So does anybody work with simulation for decision making?
Yes.
Okay, excellent. So, Arena is a discrete event simulation tool, and what we're doing is trying to improve the way that organizations make decisions. So traditionally, companies are whether it's a manufacturing company or an airport or a retail store or a restaurant, they make decisions based on on past performance and the way they've done things in the past, or on a simple Excel simulation model. So with Arena, we model with a lot more accuracy to improve decision making. That's what I want to show today. So first, a quick introduction of Rockwell and Arena. Rockwell is a Fortune 500 company, and about somewhere in the Fortune 400. So it's about 22,000 employees. Arena is a product within Rockwell. It's been around for 35 years, so it's a very well-known product, and we have hundreds of thousands of users. Arena is taught at 25 of the top 25 engineering schools in the USA, 80% of the top 25 MBA programs, those are business programs, and it's taught in almost 900 universities around the globe. So from the US to Europe to Asia, Australia, South Africa, South America, it's really taught globally. And both industrial engineering and business courses. So you said you've worked with some simulation tools in the past, so this may be a review, but I think a good place to start is what is discrete event simulation? So discrete event simulation models events that occur over time, and they include variability, system interaction to predict future performance of processes. So we say that we model events that occur over time. So we look at a shift, we might look at a day, a week, a month, a year of operations. And then we include variability, and variability can be in a processing times, and failure rates. Variability comes all across an organization or process. And then system interaction. So how does changing something on a line affect up the line or down the line? So by taking into account time, variability, and system interaction, again, we can predict the future performance of complex systems. In other words, we test things here on the computer where there's zero risk before we implement them in the real world. So this helps our customers to understand how complex systems work. It helps them to answer critical what-if questions, visualize their operations, and it becomes an insurance policy for major decisions in a completely risk-free environment. So I want to show you an example of Arena and why a tool like this is so important. So here's a basic 3 models in Arena. All 3 of these are nearly the same. We have a product coming in. It's being processed here by a resource, and then it's leaving the system. If this resource is busy at any given time, then the product has to sit and wait in this queue. So we've had the same process 3 times, in which true in all 3 of these is that the average demand is 1 unit every hour, and the average processing time is 1 unit every 45 minutes. The only difference in these models is that we have variability in the process. So, if we go into this first model, we'll see we have products coming in at a constant demand of 1 every hour. So every time the clock hits an hour, a product is going to come into the system. And then it's being processed by the resource at a constant rate of 45 minutes. So there's no variability. So I'm going to ask you guys a question here. If products are coming in 1 every hour and being processed at a constant rate of every 45 minutes, at any given time, how many will be sitting and waiting in this queue? So if they're being processed every 45 minutes and coming every hour, how many will be in this queue? The answer is 0, because they're being processed more quickly than they are coming into the system. So, when I run this model, we're going to see just that. The products are coming in, they're being processed, and they're leaving the system. This is very simple. Now, for this next model, it's the same process, but we've included some variability. So rather than a constant demand, our demand is being pulled from a distribution. So products might come in every hour and 10 minutes, every 48 minutes, every 56 minutes. It's a variable pattern. And they're being processed at the same constant rate. If I ask you the same question at any given time, how many products are going to be sitting in this queue? It's a trick question. There's no way to know without a tool like Arena. When I hit play, we see products come in. They're being processed. And because they're coming in more at different patterns, it's taking longer to process some of them, and there's more products sitting and waiting in this queue. And as we speed up time, we see the effects are greater. So we now have work in process, the waiting cost, and the jobs completed is lower or is higher than in the first model. So for this last model, we have added variability to this processing time. So it's getting pulled from a exponential distribution with a mean of 45 minutes. And now we see a lot more variability in the queue. A lot more variation. Our waiting costs are more than double. And in the long run, the jobs completed are significantly lower here. So as we add variability into this process, we get a truer understanding of the capacity of this system. So traditionally, companies make decisions on averages, and they're not able to make accurate decisions because that's not how the real world works. So by taking into account time, variability, and system interaction like we do in this model, we get a truer understanding of the real world. So visually that's powerful, but what's important is data. So if I go into some of the outputs of Arena, we can see that the very first question I asked was how many products would be sitting and waiting in first queue, and I said the answer was 0. So if we go to the number waiting and no variability queue, the answer is 0. And then I asked how many would be waiting in some variability, how many would be waiting in more variability. And here we can see that the number waiting is 2.25, and the maximum value is 14. So if you're working for a manufacturing company and they need to size a buffer, or if you're working in a hospital and they need to size their waiting room, then this is very important data to take into account. Similarly, we have waiting time. So of course the waiting time for no variability was 0, but now we can see what the waiting time for more variability was, and what the max time something spent waiting. So if you're in the food manufacturing business or pharmaceuticals, then there is a certain time period that you can produce something, or they can wait in queue before it needs to move to the next step in a process. So it's very important to understand when in that process things are exceeding that time threshold. We also have utilization data. So how often was the resource in process 1 utilized? How often in process 2 and process 3 were these resources utilized? So do you have any questions on this introductory model? How this works?
No, not actually.
Okay. So again, we're looking here at the advantages of simulation over traditional decision-making tools like Excel. One is that we return to allow us to make better decisions. So why do we simulate processes? Or why do our customers simulate processes? The first thing is to get things right the first time. So a company may ask, what if our product mix changes? How will that affect our throughput, our queues, our cost, and resource utilization? Or what if our takt time changes? What if our labor rules change? Our failure rate? What if our patient arrival rate changes? How will those things have an effect on our key performance indicators like throughput, queues, cost, and utilization? We can compare different alternatives. So if a company needs to increase their throughput, they may be able to add a shift of workers, purchase new machinery, or train their existing workers to increase throughput. So with Arena, you can test all three of those options and make a decision before you invest in anything in the real world. We can look at consolidating two facilities into one facility to determine what's the best layout for a new warehouse. Simulation helps us to avoid wasteful spending. So why purchase 10 additional items, whether those are port trucks or mixing tanks, when a lower number will be enough? In warehouses, we can look at minimum inventory needed to prevent stockouts. Lean and Six Sigma professionals use Arena and use simulation for value stream mapping and to analyze the impact of variability. And again, it can help us to visualize our problems and solutions. We communicate ideas, gain consensus, and destroy myths that have been the ground of making decisions in the past. And the big one is answer critical what-if questions before we invest in capital and without disrupting current operations. Now, simulation applies to all businesses and all business processes. So we look at manufacturing, food and beverage, airports, retail, supply chain, warehousing, call centers, banks, financial services. So Arena is used in just about every industry. And it's used in a different department. So we can look at supplier management. Who needs something? When do they need it? How much do they need? And how do we get it there? We can look at warehousing, inventory control mechanism, tactical planning, stock levels. We look at manufacturing processes, which include job routing, factory flow, capacity planning, staffing, and ERP. We look at distribution logistics, so our delivery mechanisms, shipment methods, site planning, and dispatching rules. Business processes, so that's front office, order fulfillment, workflow, and internal processes. And customer service, so we look at multi-channel contact, staffing, outsourcing, call routing. And Arena is used in the majority of Fortune 500 companies, but it's also well known in academics. So there are dozens of textbooks written for Arena. The one that from our team is called Simulation with Arena. It looks like this. And here's a list of a few other textbooks. And there are books in Japanese, Korean, Spanish, Chinese, Thai, German, Portuguese, and many other languages. It's taught at most universities that offer industrial systems engineering and operations research degrees. It's used largely in business and health, distribute that to these teams, and the student teams use Arena to try to solve the problem. The top 3 teams go to the IAE conference, which is next week in Nashville, Tennessee, and they present in front of many of their fellow students, well-known professors, and business leaders their solution, and the top team wins a prize. Actually, all 3 teams win a prize, but the top team wins a large prize. So finally, I want to show you a more complex simulation model. So the first one that you saw is very basic. Now this is a model for a manufacturing process for electronic microchips. It's animated over top of a CAD drawing to easily understand what's happening in this process. Here we have entities or products coming into a system. They're going onto a machine. When a machine is idle, it's white. When it's busy, it's green. When it's in a failed state, it'll turn red. And we see these parts flowing through this system. And our resources, whether they're machines or people, are animated depending on state. Now the logic here is a little bit more complicated than the last, but with Arena's flowcharting methodology, it's very easy to build models and to understand what's happening. We can see that in this process, we're kicking off the arrivals, we're looking at a lot size, and we assign a part type, and then it starts moving through the process. So this is the logic for the arrival process, for migration process, testing, encoding. This is assembly and inspection. So again, we use flowcharting tool to represent the system.
Okay, I think
Yeah.
that will be enough for this. So if you want just to conclude, please.
Yeah, that is the end. So if there's any questions, don't hesitate to reach out to me. And I appreciate everybody's time.
Anyone has a question for Jan? Yes.
Hello, can you hear me from here?
Yeah.
Yes, okay. I'd just like to ask you, is it possible to integrate the data acquisition from another external tool? So here in Arena, what you were showing, you have the diagram and you define the parameters for the data arrival, the product arrivals, etc., and introduce the variability. I'm wondering if you can accept that as an input coming in from, I don't know, a spreadsheet or something like that.
Yes, absolutely. And that's what we typically do when we build a model. So Arena is ODBC compatible. So whether it's Excel or Access or most other programs, you can input into Arena, drive the model, and then Arena will output your data back to that database. So usually we'll build a very easy to use tool for directors, vice presidents that don't understand the engineering aspect, but they just need to make decisions. So by doing that, they can just go in and change the number of resources, or change the schedule, or change variability, see how that affects the process. And they don't need to understand Arena in the background. So it's very easy to connect it to other tools.
Okay, thank you.
Okay, thank you very much.
Thanks, John.
So we will now
Yes,
move
thank
to
you
the
all.
next.
Bye-bye.
Thank you, bye. So we will now move to the next speaker. This is for FlexSim, Nordgreen.
talking to?
Okay, hello. You see us?
Okay, everybody's there? All right. What I'd like to do is talk a little bit about FlexSim simulation software today, and specifically kind of how it helps in managing waiting times in simulation. So what I'd like to do is kind of go through a couple slides here real quick, talk about what waiting time is. Waiting time, basically three types of waiting time. You have your customer waiting time, your product waiting time, your machine time waiting time. And I've kind of ranked these by costs. Most expensive waiting time is that of a customer who they wait too long, they go somewhere else to buy their product, and therefore you have no business. The second most expensive is your product waiting time. These are parts waiting around the facility or in the warehouse, waiting to be sold, so forth. The third most expensive waiting time is machine waiting time, and that's idle equipment or resources you might have in a process. So we kind of look at how these waiting times are allocated. This little graph here kind of shows you a dynamic chart that shows that these waiting times compete with each other. So if you want to decrease your customer wait time, you increase product waiting time or machine waiting time. A good example of that is if you wanted to have everything in store waiting for a customer to come in and buy it, your cost of product waiting would go up because you'd have to have a lot of inventory costs. And so in any kind of process, you have a tug of war going on between these three types of waiting times. And this is every manufacturing philosophy, lean manufacturing principles are designed to help you reduce waiting time. They call it waiting time waste and lean waiting time in the facility based on these three types of waiting times. So kind of the waiting time law is the higher the utilization of the process, the larger the queue is from that process. So the goal here is to look at utilization versus waiting time. We can see in this little chart here, as utilization of the equipment moves up over 90%, that you have a higher chance of waiting in the queue a lot longer, and that time goes up exponentially as the utilization approaches 100%. And so what I'd like to do real quick today is just see if we can prove that this is actually true using simulation software. So what I'd like to do now is just show you a out a average state time chart here. We'll look at Q3 as our object we're going to look at here, Q3, and we'll look at the average state time of Q3 here. So these are kind of the two things we want to look at as we run this model. So I'm going to set up the stop time. We'll run this, our default time units are in seconds, so 8 hours worth of time in 28,800 seconds. And then we'll go ahead and we'll just start to run this model. And we can see as we start to run the model, we can look at the utilization of the processors are now going up and approaching, we'll approach about 99% utilization. As I speed this up, over time we can see that the average stay time or wait time in the queue is increasing as we run. As the utilization now gets up close to 100% for the processors, our average stay time will start to build, and you can see the queue building here as a result. So if we go ahead and we run it now for the full 8 hours of time, we can see that the average stay time of our parts is over 300 seconds. And so if we were to look at a pie chart of processing time versus wait time, we can see that we're generally processing about 80% of the time these boxes are in the system and waiting about 92% of the time in the system. So if we look at our chart again, we can see that as utilization goes over 90%, our wait time is going to be very high, exponentially distributed. Now, as we look at our model here, we can see this wait time is very high, and our utilization is very high. So what can we do to reduce the utilization of these processors in this model? Well, there's three things we can do. We could reduce the number of boxes coming into the source, which might be customer orders, so we probably don't want to do that. We could add a fourth machine, but that would be an expensive option, but we can do that as well. The third option would be to maybe send our operators to school and see if we can reduce process time on the processors a little bit, so we can get a few more through. So let's take that option in this case. So I want you to remember right now the utilization percentages we have for the equipment and the average stay time that we have for the queue. So it's 328.8 seconds on average stay time for every box in the system. What we'll do is we'll reset the model now, and we'll come into each of the processors, and we'll reduce the time 10% on our process time. So we'll move the process time from 30 down to 27 seconds. So it's not a real big change, it's a small change. Reducing the process time just 3 seconds. And let's take a look after we reduce that of now how the model is going to run. So if we start to run it, we speed it up here so we can run the 8 hours very quickly. We'll see something interesting here. First of all, the utilization of the processors dropped about 10% in this case. So now we have idle time, and so utilization now dropped down to about 90%. Now, if we look at our chart here, by dropping our utilization down to 90, we should see a significant drop in the wait time in front of those processors. Well, let's see if that's really the case. And in this case, we've dropped now, the wait time is 328 up, I'll make a center port connection, and then when I click on the queue, I will just check this box here that says use transport. So we use that operator. So now if I hit reset and run, when we run this system for 8 hours, you can see this operator now carrying the boxes back and forth. We could also probably want to add a new chart where we look at the pie chart of our operator now, so we can see what his utilization is during the simulation here. So. Now what's interesting here is we see a drop in utilization of the processors, and that's to be expected because the operator can't be everywhere at once. We also see the average stay time moving way up in the direction we don't want it to be. You can see the box moving up. But we also look at our operator, we can see that he's got 30% idle time. So how do we explain this? We can see that he has travel empty and travel loaded, and other travel time here. We've still got about 30% idle time. And that's the time that he has once he's loaded all 3 machines. So once he gets all the 3rd machine loaded here, he's just going to wait because there's nothing to do at this point. And so a lot of the time is taken up based on how far the queue is away from the machine, how long the process is, and so forth. And also, maybe how many operators we have. So maybe we'd like to run an experiment to see how many operators we would need to staff this cell to get this through. What I'm going to do here is I'm going to change this configuration a little bit by using a dispatcher. The dispatcher is an object that allows me to send the calls to the dispatcher for transport, and then I can pull out a number of operators here and connect those to the dispatcher, and then the dispatcher will assign the operator to pick up the move part. So let's say we put 3 operators out here, and we started to run in this case here. So we can see now that utilization of our first operator has dropped a little bit. Utilization of equipment has gone back up a little bit, and our wait time is going up still a little bit. It's not as bad as it was previously. And we could even say, well, what is the best configuration of operators maybe to run this to reduce that wait time? So we could also run an experiment here where we could determine the number of operators that we might use in this cell. And so in this experiment here, I'd like to choose the number of task executors. This would be our operators that we might use. Let's have 3 scenarios here where we use 1 operator, 2 operators, and 3 operators. And then let's look at some performance measures. Let's look at the state pi of our average processor time. Let's also look at the average state time of our queue. Let's also look at a state pi chart of our first operator that we put out here to see how that moves. We also may want to look at the throughput. So I can use a standard performance measure here that we call throughput. And we could say, okay, what do we want to look at? We want to look at the individual object. We want to look at the input of our sync here. And that would give us our throughput of the system. So now that we've got the experiment ready to go, let's say that we want to run each scenario 20 times of day each. We want to run for a full day, which is 2,800 seconds, and we're ready to go. So if we run the experiment, FlexSim will set up the 20 runs for each one. My machine has 8 cores in it, so we're going to run simultaneously 8 experiments at a time to look at the results here. So we'll run all 3 scenarios. So we've run, when we get all 3 scenarios finished here, we've run 60 days worth of simulation. And now we can view the results of this run. So kind of look at the average utilization operators here. We can see that when we use one operator, our utilization is about 73. When we get to 2 and 3 operators, the actual utilization goes up a little bit for each operator. If we look at the average stay time in the queue, we can see that one operator, we have an average of 25.91. 2, we go down to 22, 22, and 3, we go down to 22.20. So not much of an improvement at all with third operator. You can also look at the our utilization of first operator will also go down significantly, but it stays about the same when we add third operator as well. And then we can look at throughput, and when we add second operator, throughput goes up, and we have a third operator, it stays pretty much the same. So given the results of this experiment, this cell would probably run best with 2 operators working in here. We get as much throughput, much average utilization on our equipment goes up a little bit, doesn't go up anymore. We use 3. We can see that the average stay time in the queue will drop. Addition of 1 operator, the third one, it stays about the same. So, do we have any questions right now at this point on anything that I've covered?
I don't think so. You may continue.
Okay. So looking at FlexSim a little bit more, FlexSim allows you to build discrete event and continuous models. We have a fluid library as well that handles tanks and pipes and mixers, which you can do continuous as well as discrete event. And we have objects that convert from fluid to item and item back to fluid. We have special modules that do very complex conveyor and HEV logic as well. And the customization aspect of the software is very good. The 3D aspect of it, if you want to change the standard shape of the 3D object here, we go to the General tab, and under the 3D shape, we browse for shape here. You can see that down here at the bottom, you can see all the different file types that we can bring in as 3D objects. You have VRML, 3D Studio, AutoCAD, Google SketchUp, DAE, OEJ, COB files, anything you'd want to look at. So if we wanted to change this machine to some other type of machine, we could look at, let's say, for example, we wanted to change this to a desk. We could just pull in any kind of object we wanted at this point, and we could change that animation very quickly to whatever we'd like to have that be at any time. It's easy to turn on shadows and shading, give you an idea of kind of the types of things you can simulate and customize. When you open a model here, give you a good idea. So in this model here, we can even bring in a nice floor if you'd like. What you can see as we run this, run this model here.
Someone wants to ask a question? Anyone from the audience? No?
So Bill, thank you for giving the presentation.
Okay.
We will award the prize tomorrow, so thank you for supporting this conference.
Okay.
Have a nice day.
Thank you. Bye.
Right. Thank you.
Fine, thank you. So if you're ready, we can start with your presentation. So,
Yes, I'm ready.
yes, go ahead.
So, okay, can you see my WebEx okay?
Yes, we can see it.
Okay, so quick question. How familiar are you guys with simulation modeling?
Not so much.
Okay. Well, let me do a brief introduction to simulation, and then I will also get into ExtendSim. First of all, when we talk about simulation models, simulation modeling is a way to study real-world problems, where oftentimes systems too complex to analyze with spreadsheet flow charts. So a simulation model gives us the power to model these systems that are fairly complex.
Robin, sorry to interrupt you. You have something in front of the presentation. Do you have something in front of the presentation, or is it ours? It's ours. No.
I think he has a window on top of it, and he's just sharing the PowerPoint.
So can you hear me?
We have some
Can you not hear me?
we have some gray windows in front of your presentation, so we cannot see whole page.
Okay,
Okay, now it's better.
No, it's fine. Okay.
Okay.
Go ahead. Yes, everything is fine now.
Okay, everything should be okay, right? Some of the, ExtendSim does simulation modeling, and we get to three aspects of simulation modeling: continuous model, discrete event model, and discrete rate model. Continuous model would be where someone might want to model the rate of flow. For example, if you're looking at the autonomous stream of fluid passing through a pipe, the volume may increase or decrease from the tank, but but for a continuous model, the time step is going to be a constant time step. You're simulating time step 1, 2, 3. There's no real discrete events in there, but constant time intervals. Discrete event modeling is where you're looking where the system changes as events occur. The passing of time has no direct effect on the model. Events occur seemingly at random intervals of time. That would be like the manufacturing plant when you're producing widgets and gadgets. Finally, discrete rate modeling is a combination of the continuous and discrete events. And that is one of the unique aspects of ExtendSim, how we do that through the discrete rate modeling. This would be a system like if you're modeling a high-speed manufacturing plant, where the rates are really too fast to model individual items, but you still want to model the characteristics of the discrete events, such as machine failure. And the reason ExtendSim is unique to this is because we have a linear programming optimization going on behind the model to optimize the network. Some of the advantages of ExtendSim is its interactive you're encapsulating more of a higher level kind of a construct there. So in this emergency department, we have people coming to, arriving into the system. They go through the triage where we determine how sick they are. They go through registration. Then they wait on a treatment room, and there's two possible treatment rooms they might go to. A regular emergency department room or a fast track room. So the fast track is where, basically it's where the not so sick patients get some frequently. At the end, we are looking at some of the roll-up statistics of the three types of patients. The patients that are going to be admitted to the hospital, the patients that are going to be discharged, and the patients that are going into the fast track area. Now, what I'm doing is, with this model is, while it's running, I'm animating on top of these H-plots so you can see the average patients per day coming through these areas, and the length of stay, which is the two primary measures for this system that they were looking at. Now, this is just one way to animate in ExtendSim. If you actually had the actual layout, well, you could put the actual layout in there and show the patients as they're entering and leaving the room. Some people like to build their model with the actual layout. Now, it doesn't show much, this view of it doesn't show much about the process. You would have to go inside and look inside of the ED, inside the H-plot to see the process. So you would be able to see for sure, based on the time of day, how many people are occupying the room, how busy they are. So I mentioned to you that it's very interactive. Well, one of the things I want to show you is, while the model is running, if you see that maybe there's too many rooms or not enough rooms, you can put controls in there to change the number of rooms while the model is running. So you can make changes to the input data as you're running the model. Now, when you're doing experiments, you don't want to do that, but after debugging the model, making those changes on the fly is very helpful. We also have, you can also write your own custom components if you want to, and that's one of the things I really like about ExtendSim. And it's actually part of the name. ExtendSim is part of the ExtendSim's name is for extensibility. If you wanted to create your own custom component, you can do that. If you look at the plot that I have here in this window, that is one that I created myself. ExtendSim gives you, a pretty good development environment in case you wanted to write your own block, author your own block, and write your own code. It's very similar to C. And so because of that, there's almost nothing that you can't do in ExtendSim. If there's not a tool for it there already, then you can create your own. Now, most people don't go off and create their own tool. Probably only about 10% of the folks that use ExtendSim would go off and do the coding themselves. But if you wanted to, you have the capability of doing that. Now, oftentimes what I find in complex projects is there is always an instance or two where the customer wants to see something done in a specific way. So being able to do the development yourself, then you can pretty much do anything that they care to look at. And we would put them into a library like I'm showing over here to the top. So this is my custom library for this. And it shows the clock there. And that not only can be this model, but other models. For those components can be reviewed. Talking about these models, there's two ways to do it. One way is if you wanted to build it kind of like a flowchart view, as we have here. As patients come in, the patient seeing the doctor or seeing the nurse, and then they get discharged. Well, for the fast track, the way I built it is this one construct here can handle all the patients in the construct area. So whether the fast track area
had 4 rooms, 6 rooms, or 8 rooms, we're using the same set of blocks, and we're just setting the capacity up so that no more than, say, 4 time will be in here. Or if you went into more detailed view of it, with the ED room, I built it a different way, in which you notice as the model is running here, I have these 24 emergency department rooms, and you can see the patient in the room as the model is running, checking into and out of the room. And here, each of these constructs represent a specific room. So you can see a specific room would have possibly a doctor visit, a nurse visit, a lab, and that second follow-up visit with the doctor, and determining whether you're going to be admitted or discharged. So with this concept, we're able to create a reusable component for this room and replicate it within this model, as well as put it into a library and use it in other models. So if we're building systems where you can build this set of blocks that can be reused, we provide the tools that allow you to do that for you. Now, within this H block, there's, more H blocks underneath it. This H block is called a hierarchical block. And we can go as detailed as you need to. So typically, when you're building a large model, doesn't matter how large, but you try to keep it to one screen dot wide, and just build H blocks around it. So if there's more detail, you put it into a thumb button or some H block. Another thing that's unique about ExtendSim is we have a very strong database backend. So those blocks that you see, we could put the data, like for the service time, inside the blocks themselves. But we could also come in from the database and build the data into the database. That way, no matter how large our model is, we can access, any of those service times or probabilities through this central database. So you can see from here, the triage area, that's between, it's a log normal distribution with a mean of 3 minutes and a standard deviation of 2 minutes. And that can be changed to the random number distribution dialog here. So any of those penalties in distribution we can easily change. But because we typically have large and complex models, we don't want to embed the data throughout the block. We want to put it into a simple area that all the blocks have access to. So we want to scan to see what our service times is for all the processes, or all the interruptible time. All of that is contained in one place. Which makes it also easy if we wanted to import and access the data from other sources. Well, now that our data is comprised of the database, then importing or exporting from Excel or Access or any other database type of a tool is fairly simple. These tables can be imported or exported as needed. As well as if we look at the results, we can count, not only can the database be used for data coming into the model, it can also be used for output data. Let me run it real quick so we can see some output data. And see here, we wanted to look at for the different patient types, what their average length of stay in patients per day is. Well, we can see it on the front screen, but we can also put it into the simple database and keep track of it through the database and export the results from the database. I'm also keeping track of the 24 emergency department rooms through here, the number of patients completed and their utilization of each of the rooms. You'll see that, the first few rooms that in the ED are very highly utilized, but the last few rooms, well, they don't see that very many patients. Their utilization is pretty low. So this would have us go in through here. Maybe we might want to turn off some of those rooms where we have less than say a 20% utilization rate. So not only can I see utilization in the grand scale, but I can also see the utilization for each of the individual rooms. But having the simple database in there is a neat way of interacting with the model. I'm also keeping track of the patient log. we're basically building a system that does not exist, capturing a data on that system that does not exist, and doing an analytics side. So, it's easy to do analytics on systems that, you're collecting data off of the web for, or the internal ERP system, grabbing data off of it. The simulation model can generate that same type of data for systems that do not exist. So we can see, even though the current system might only have 18 rooms, we could build a simulation model and see how that same system would react with having a different number of patient rooms. So to recap, some of the neat features of ExtendSim is it's very, it's very visual. You can build models like you would a flow chart. You can animate it, like we have a flow chart here. You can animate it if you have the actual image of the real system. You can create your own custom block through their development environment. You can create H blocks to take large models and compress it into smaller subcomponents, and those subcomponents can be reused. And we have a nice database backend to where we can capture our output data in any format we need. We can put in our input data in any format we need to have access to it. And we can interact with other data sources outside of the ExtendSim. Any questions?
Do you have any questions?
Well, for something a while ago, just out of curiosity, what language were you using to define the blocks? So the actual definition you showed a while ago, you could redefine what the block was actually doing. I wasn't able to identify it, just showed up too quickly here. So what kind of programming language are you using there?
It's something very similar to C.
It looks like C.
Or C++.
Okay.
Now, it's not object-oriented, but it's very much C-like, and it does have some C++ features. So this would be a custom block that I developed. You can also go into any of the standard blocks and have access to the standard blocks as well. Now, typically we don't modify the standard blocks. You could, but what I'm using the code in the standard blocks for often for is if I need to do a specific feature that I know that already exists in one of these standard blocks, I'll go into some of the standard blocks, copy the code, and write it myself.
Okay, thank you.
So again, most people would not be using the code to program their own block, but if you wanted to, you're more than welcome to it.
Okay, Robin, thank you so much for your presentation. So we will go to the next presentation. Thank you for giving this presentation.
Thank you.
Okay, Max, you can start.
Okay, good. Well, thank you so much. I appreciate the chance to join you and can see you a little bit. Can you hear me okay?
Yes.
Okay, good. And my apologies for missing the time earlier. Because we had, I'm thinking it was CET, not CEST.
Yeah, sorry, I didn't.
So, not at all my fault. So, I'm going to talk about, let me see, I'm sure you can see this okay. So, can you see the screen okay?
Yes.
Okay. So, this is a particular decision support system and a multi-attribute decision analysis for a project top of Southern California. And, you know, I think you may find it interesting. It had certainly quite to me, surprising outcome. Going into it, this was one of the most challenging decision projects I've worked on in a number of years, in terms of the complexity, the number of stakeholders, their differences of opinion, it ended up being one of the most satisfying projects in terms of actually getting towards a consensus among these apparently conflicted stakeholders. So I'd like to talk about why what decommissioning offshore oil platforms is about, why it's a challenging problem. And the process that we went through in terms of analyzing the options, setting up the decision support model, and the solution that we came up with that satisfied almost all the stakeholders. And finally, extract some lessons learned from this project. So, this is a photograph of Huntington Beach in Southern California in 1926. Oil was discovered there in 1920, and 6 years later you can see this forest of oil derricks. And each of these derricks is actually made of old-growth redwood trees, the famous redwoods from California, which are now highly protected, but in those days were used as an industrial resource. And decommissioning these when the oil came out was actually quite easy, because contractors could take this wood and resell the lumber, which was quite valuable. And when I was in Huntington Beach about a month ago to give another version of this talk, these derricks are long gone and it's replaced by luxury hotels. It's just south of Los Angeles. And the view from Huntington Beach, looking out to the Pacific Ocean, looks something like this. You can see a couple of offshore oil platforms in the distance. And these are much less visually intrusive on the land, but turn out to be a little more complicated to get rid of. So this is a map of Southern California. You can see Los Angeles and Huntington Beach, a bit south of Los Angeles. Each of these blue dots is an offshore oil platform, and also the red dots, which are in the state jurisdiction. And they were put in to the ocean 1950s, 1960s, some 1970s, and when they come to the end of their productive life, which is pretty soon, the leases require that the platforms are entirely removed and the ocean is restored to its original state. And some of you may be familiar, there's a similar issue in the North Sea now, where there's over 800 such platforms, some of them coming to the end of their life, and the question is how to decommission them, how to remove them. So let me just identify a couple of these. Platform Harmony is the largest of these platforms, and I'll talk a little about that. And Platform A, which has rather an innocuous sounding name, became quite notorious. In 1969, it was a blowout during drilling operations, and it was one of the largest early oil spills, a Santa Barbara oil spill of 1969, that destroyed the beautiful beaches around Santa Barbara, and photographs of the dying sea life, dying birds went around the US, probably around the world in fact, and have been credited with jump-starting the environmental movement in the United States. And to this day, more than 50 years later, anything to do with offshore oil is highly controversial in California. Even the issue of how to decommission these oil rigs. So one of the challenges is just the size of these things. So I don't know if any of you have seen them or been on one, that what you can see here is pretty huge, but that's just the tip of the iceberg, because under the water there's a support structure that can be many times larger. And here's a photograph of platform Harmony before it was installed. And if you see that crane, this is a really large crane, a truck. So and you can see this thing is massive. And it's actually taller than the Eiffel Tower or the Empire State Building in terms of its depth. And more than that, if you look underwater, this is what these things look like. So these original steel members are coated with, up to a foot thick or more with marine life, corals, sea anemones, shells of all kinds. And fish breed on here, especially rockfish, which are quite commercially valuable. The ocean floor off Southern California is sandy and pretty flat, so it's actually not very interesting for people and not very interesting for fish. So they actually like these platforms, and the nutrients that the plant life and shellfish live off drift through the open network and make them highly productive biologically, which brings in a variety of marine life, seals, porpoises, and even human recreational divers go down there because it's kind of more interesting than the flat sandy floor. So there's a whole set of stakeholders that care about this issue. Here's just a few of them. Federal and California state government agencies, especially the California Natural Resources Agency, formerly Fish and Wildlife, a variety of environmental groups, NGOs, the Ocean Conservancy, Greenpeace, and others. Chevron and other companies that own and operate these platforms obviously care about this, and commercial and sport fishing. And these groups had rather different opinions about what should be done here. And the California Ocean Science Trust, which is an NGO that is focused on science and policy relating to the ocean in California, decided to bring together a group to study this, to look at the options. And they had Brock Bernstein and myself and Surya Swami. And I should say, Lumina Decision Systems is primarily a software company. We produce the Analytica software that some of you may know, and that we're offering a free copy of Analytica Enterprise as a prize, I believe, for this conference. And we also have a more limited free version that any of you could use, including to look at the model that we developed here. And Brock Bernstein put together a team of people, unlike myself, that actually know important things about this topic. I know something about it now, but when we started out, I was a decision analyst. So these include marine ecologists, economists who looked at related issues, offshore engineers who can understand how to dismantle these platforms and so on. And we were, obviously, something like this, you need a multidisciplinary team, and we were also aided by an advisory committee set up by OST with professors and representatives from different stakeholder groups. So what we did was build a decision support tool in Analytica and start by sitting down with the experts, both in our team and some of the other stakeholders. First of all, to figure out what do they really care about, and what are the options that we should be looking at. typically we would sit down in a room and draw up influence diagrams using Analytica to represent the various issues. So here's kind of a close-up of that top-level view of the diagram. So down the middle here, we have a list of 8 objectives, or what decision analysts like to call attributes, things that the stakeholders care about. On the left, the decommissioning options. And so first I'm going to dive into just a few of these modules to give you a taste of what this is about. First into the decommissioning options. So we structure these as a decision tree. So the first branch is simply complete removal as required by the leases, and then there's various different options about how to cut the piles, whether to use explosives, how to dispose of the remains, whether to take the bits of steel and all the sea life attached to it on land, or dispose of it in deep water. Or an alternative option might be to see if we could actually leave these things in place and reuse them for something else. So the most kind of appealing options seem to be to take these monuments to fossil fuel extraction and repurpose them as platforms for renewable energy, especially for wind turbines. Sadly, it turns out that that isn't really practical. They're not really laid out in a way that is economically or technically viable for wind turbines all the way. So we also looked at an intermediate option, which is partial removal, essentially taking the top platform off, but leaving a lot of the support structure in place as a kind of artificial reef to retain much of the marine systems that have grown up on them. And again, there's various options looked at. This is just a subset of the decision tree. The darker green things are things that we analyze in some quantitative detail. The lighter green ones we proved out based on kind of exploration. It became apparent that they were not really either technically or politically feasible. And this is a typical process in this kind of problem. When you explore the options, you can get an exponential number when you combine all decision options. And the trick is to prune it down to a small set that really are promising and capable of analysis. So for partial removal, as I said, we chop the top off 85 feet and about 25 meters below the mean sea level, so that it won't be a hazard to shipping. But in fact, a lot of the biological productivity is below that depth, and so retained. So let's dig into one of these attributes, the economic costs. So we sat down with experts on platforms and engineers to estimate the decommissioning costs. So drew up this influence diagram. So the ovals here are uncertain quantities, elements of the cost. And we initially draw up a diagram like this that's qualitative, and then try to put numbers into it and do a probabilistic analysis. So we figured out that although there's not been any platform decommissioning projects in the waters of California, there have been several in the Gulf of Mexico, over 120. So we were able to look at what did they actually cost, compare that with the cost estimate, and say what's the percent error. And so we said, well, in California maybe there would be a similar percentage error, and so we're able to estimate a probability distribution of the cost. Here's the cost for one of the smaller platforms, platform Henrion, for both partial removal, where we just chop off the top, and for complete removal. So let me dig into air quality. So this is a heavy lift vessel that can lift about 4,000 tons, and you're going to need one of these things to lift pieces of the platform. Imagine trying to lift the Eiffel Tower out of the ocean. Well, in pieces, but still large pieces. And most of these heavy lift vessels in the world are actually right now in the North Sea, where they're erecting wind turbines. So you'd have to rent one of these things. They're too large to fit through Panama Canal, so it has to go around the south of South America. Cost $2 or $3 million a day to rent, and actually generates a significant amount of air pollution, even just locally. And the California Air Resources Board looked at this, and this was a concern. One other item, the impact on marine mammals. So there's, I like to go kayaking myself in the ocean near where I live in Santa Cruz up in North California. I'm originally from England, as some of you might be able to tell from my accent, but I've been living in the US for quite a few decades now. And when you go kayaking there, as in other parts of the world, there's quite a lot of wildlife. Seals, sea lions, sea otters, occasional dolphins and whales. So for each of these attributes, in this case impact on marine mammals, we identify a best level, in this case the status quo with no impact, and the decision we know actually assign that a score of 100. And then a worst level that could be created by decommissioning, which would be if we use explosives for severing the platform, which could cause possible mortality, especially among seals. Give that a 0. And then there's various intermediate points that we assign an intermediate number between 0 and 100. Now this would be the perspective of a particular stakeholder that has this view. And well, here's a picture of one of our more vociferous stakeholders expressing his opinion on this topic. This is supposed to be a joke. Although he is obviously an important
Yeah,
stakeholder.
you understand, we're just a little bit tired, so... because it's 7 p.m. here, so...
Yes, okay. I will move ahead. Very good. I'm sure you're ready to have your dinner. So I will skip through some of these. So we, through each of these attributes, we assess a best and worst level, and we order them from which attribute we consider the give that 100, in this case it was cost, and assign a weight to each of the other attributes. Now, for each person assessing those, they're hard to assess. Some uncertainty, and of course, different stakeholders will have different opinions. So we do a sensitivity analysis to figure out what's the importance of the effect of varying each weight from 0 to 100 on utility difference. So this is the difference in utility between partial removal, the rigs to reefs option, and complete removal. So positive means we prefer the partial removal. And you can see only one of these bars, if you take it to an extreme, in this its maximum weight, it's sufficient to change the utility difference to be negative, meaning sufficient to favor complete enough to change the decision. And that's an interesting outcome. And we need to do this analysis for each of the 27 platforms, so we create a strategy which doesn't necessarily have the same option for each platform. And so here we listed the platforms by depth from the shallowest ester down to the deepest harmony that we saw earlier. And then we changed the weight to strict compliance. That's how important is it that we comply with the leases and have to remove the platforms entirely. From 0, saying we don't care, up to 100, meaning it's the most important attribute. And as we change it, we can see the color goes from light blue, meaning that we prefer partial removal or raised reads, to dark blue, meaning we prefer complete removal. So this is a way to visualize for the stakeholders, you know, what matters and how we change this controversial issue, how it would change the position for each platform. So finally, after delivering a report, 268-page report to our clients in a series of workshops, one of the stakeholders said, well, this is fine, but this is just too complicated. Couldn't you just summarize the recommendation in a single page? And so that's what we tried to do here. So there's basically 2 options that seem plausible: full removal and partial removal. And here we just listed the key attributes that carry. So for partial removal, it would require a lease waiver. It retains most of the biological productivity and minimizes the environmental impacts and saves over $500 million. But you know, it saves the $500 million to the oil companies. So some of the environmentalists felt, well, you know, why should we save money for the oil companies? So in that case, we came up with a wrinkle on this. What if we save that, split that money between the operators and have half going to an ocean conservation fund to be administered by the state of California? And with that option, almost everybody agreed. So we waived the strict compliance law, split the savings, and a reach-to-reach bill was passed by the California State House with almost complete consensus. Only 3 lawmakers, 3 representatives were against it. And here we see our former governor of California, Arnold Schwarzenegger, signing that bill as one of his last acts as governor of California. So here's a few lessons learned. First of all, we found that by interacting with this decision model, stakeholders were able to gain a level of confidence and insights that I don't think that they would have gained simply by a paper report. Secondly, that sensitivity analysis on the numbers lets us work with approximate numbers. And you know, in these kinds of studies, as I'm sure you well know, many of the numbers are inevitably approximate. Thirdly, I find quite often in these decision analyses a little bit of ingenuity. One can sometimes generate a new decision option that actually can bring more of the stakeholders along. So in this case, splitting the savings. And finally, that this kind of decision analysis process with a decision support software can help illuminate decisions, even, perhaps especially, when there are strongly conflicting perspectives. So, do you have any questions or comments?
Well, I have just one question. If you had to explain the difference between expert choice, A, B, and the decision process supported in Lumina, what would that be?
Sure. So I should say the multi-attribute decision process that we went through here is a fairly widely used method by decision analysts. And there have been a number of studies comparing AHP with multi-attribute decision analysis. And, you know, on the surface they look pretty similar, but AHP actually has some features that are a bit problematic. For example, depending on how you structure it, you can end up with intransitive choices so that you can set up attributes such that, you know, I prefer A to B, I prefer B to C, but I prefer C to A, you know, which is illogical. And it's basically the underlying model in AHP is not so robust. But I'd say the key in doing this kind of multi-attribute is kind of identifying the key attributes, you know, which is the same for both processes depending on the skill of the analyst. Let's see. Any other questions?
No, Max, thank you a lot for this presentation. Thank you for supporting our group.
Well, you're very welcome. I also want to say, you know, if anybody wants to learn more about this, if you go to this URL, there's, you know, some short papers about it. You can even download the model if you'd like, the platform model to play with it yourself. And I'm actually going to be presenting a version of this in Glasgow at the end of this month. And we're looking at applying this in the North Sea, so a little bit closer to home for some of you, I imagine. So I really appreciate your attention. Thanks so much, and if you have any questions about Analytica using it, you know, please email me and get in touch. Thanks so much.
Thank you. Bye-bye.
Cheers.
Bye.
Okay, guys, so we are done with virtual presentation. We have just one more short presentation from Nataša, our sponsor. Please, Nataša, take the floor. I'm so happy that we are finished with virtual presentation. Whoa. No. I'll close this just in case.
companies, but also for small business owners, for small family-owned companies, and for some of the biggest public institutions in Serbia, Croatia, and Bosnia and Herzegovina, such as Ministry of Defense, Ministry of Justice, and others. We also implement and maintain standard business solutions developed by Oracle, Microsoft, and others. Those are enterprise resource planning solutions, business intelligence solutions, CRM solutions, warehouse management systems, and others. Within the Into Group operates a data science company. They employ a team of professionals and experts well known in academic and business circles, and their main job is to maximize the return on data collected throughout the regular business operations. So they use predictive models, they use social CRM, data mining techniques, and so on to filter the data which can be useful for the company from those who are not. We are involved in IT business consulting. We advise our customers on multiple areas, ranging from advices on network infrastructure to optimization of business processes and automation of processes. So we also provide technical support, and as I've mentioned previously, we are involved in integrated security and digital forensics. This is the list of some of our solutions. You will see probably some solutions you are already familiar with. Those are the standard business solutions developed by our partners. But in the second column, you will see the solutions developed within Into company. We develop solutions for financial sector, for insurance companies, for healthcare, pharmaceuticals, retail, wholesale, logistics and distribution, and so on and so on. I'm not going to get too much into it. I'm going to show you just some of our different references. We're especially proud of our corporate culture. We believe that only the quality relationship with the customers and environment and employees can lead to healthy growth. So we are happy to share with those who are less fortunate than us. We organize fundraising events, we donate software, we donate funds to hospitals, to students' organizations, we support sports teams, and so on. Also, we are well aware of the fact that the people are our employees are the main driving force behind our success. So we continuously invest in their education, motivation, and we encourage their creativity. So that's basically how most of our solutions actually were developed. We work closely with students' organizations and with universities. We hire young people. We have an Into Academy. It was established for only one purpose, to educate students. And most of these students, after they finish training, they stay with us. Some of them run their own teams. Some of them are members of the board, so they're all pretty successful. With clients, we tend to keep long-term relationships, so we treat them with professionalism, and we individually approach each one of them. So all of this makes up a corporate culture that's really recognizable, not only within a company, but also on the market. Because we spend time together, we play sports together, we have a football team, both male and female, and the female team is much hotter. And we play hockey on ice, really. We sing, we organize parties, we have a musical band who plays on all of our parties. It's really nice. And it brings some visible results. Our solutions have been globally recognized. We have been awarded the Microsoft Partner of the Year Award and the European IT and Software Excellence Award for our healthcare solution. And here you will see the list of our Microsoft and Oracle competences. But these are not the only companies we nurture partnership with. This is the list of other partners. So which brings me back to the beginning of this presentation. That's it, I swear. So I just